Welcome to Pointers, where C gets really interesting. There's a quote here from a guy called Henry Baker about why C has been such a problematic language, and there's also a cartoon from XKCD about pointers, which is just for your entertainment. Pause the video and watch or listen or read or whatever if you like. I'm moving on. Crash alert. So, as I've said several times, you have to regard memory in C as just a huge array. Pointers are things that point somewhere into that array, and if the somewhere that they point isn't where you thought, and you try and store some data there, then of course what happens is something breaks. If you're lucky, what happens is you get an error message like segmentation fault core dumped, and your program aborts. In Windows that corresponds to this message: this program has encountered a problem and needs to close. If you're unlucky, what happens is that your code continues on blithely, only with something corrupted. And so you get some wrong answers, and you don't necessarily even know that they're wrong. And of course, you could even go away and publish really fascinating research reports on the outcomes of your studies. We won't go there. Let's move on. Another XKCD cartoon. Again, read it if you want to pause the video. I'm just going to point out the last line of that, which is, double check your damn pointers, okay? So what are pointers? Well, pointers are easy. Any experienced programmer will tell you that pointers are trivial, and even experienced programmers can't generally recall why they ever thought pointers were non-trivial. Let's see how you go on them. Let me show you how simple they are. Here's a variable I. It's initialized to 10. Here's another variable j, which is initialized to 20. Here's another variable, this is the interesting one, int star p, and I'm going to initialize it to the value null. So what I just did is I declared a new variable p, which is of type int star. You have to get used to reading the cryptic notation of C. You have to get used to seeing that in your head as integer pointer, p is null. And the word null isn't part of the C language, it's a hash define in one of the various includes. It's hash define null to be 0. So this just had the effect shown here. We declared 4 bytes for I, we declared 4 bytes for j, we declared on the lab machines at least 8 bytes for a pointer. It's a 64-bit architecture. It takes 8 bytes to represent 64 bits. If you're on a 32-bit machine, that will only be 4 bytes, such as, for example, a Raspberry Pi or the little micros you'll use in the second half of the course. We plant the value 0 into there. So because it's a pointer, it points at memory location 0, which actually is an illegal place to point. So that won't work usefully yet. It's initialized to a non-useful value. As the note here mentions, the declaration of pointers can be done in at least 3 different ways. You've seen one. Here's a second one with a space on either side of the pointer, the star, and there's a third one. This third one is the one that the textbook uses, and it's probably the most common in the C community, whereas the one I favour is this one here, which is the most popular in the C++ community. It reads to me more naturally as int pointer p is equal to null. So that's the one I'm asking you to use in this course. What can I do with it? Well, at the moment I can't do anything with it until it points somewhere sensible. So let's point it at somewhere sensible. P is the address of I. Now I've done that a few times when we've done things like scanfs. I've read that word, the ampersand, as address of. Again, cryptic notation in C. But that's what it means. It's perfectly simple. And here's the picture we now have. Remember that memory in C and on the actual machine is just a whole heap of 1 billion or more little boxes, each one containing 1 byte. And the little boxes are numbered. And those numbers are addresses. So if 4 bytes together, if this was the variable I here, for example, then the address of I would be that number, 1001. The other one's just following on. So that's what that's saying. It's an assignment statement which places into a variable, in this case the variable p, a particular value which is where I is in memory. So what can I now do? Well, let me slightly vary the lecture notes a little bit by printing the decimal value of the memory item that p points at. So now we have to read star in a different way. This star we read as pointer, so that says int pointer p is null. This one we read as indirectly through. So this is the one that comes before the variable. This is the one that comes after a type. So this says print as a decimal number the variable that we get to indirectly via p. Let's compile and run it. Oh, I got an error because I haven't used j. That's just a minor detail. Let's run it, and it says 10. It says 10 because star p indirectly through p is I. So in fact, since I've set that up already, star p just means I. And because star p means I can now add an extra line here. I can say, let's go star p is equal to j. Remember, star p is essentially I, so that's an equivalent to the assignment I equals j. Let's just check on that. I equals percentage %d, comma, j equals percentage %d. And I'm going to print I and j. Let's run it. Compiles and it runs. So I is 20, j is 20. So we started off with I is 10 and j is 20. We did the assignment star p, that's that target is there, is equal to j. So we picked up that 20 and we pushed it along that arrow. And as a consequence, they're both 20. No difficulty there, is there? Perfectly straightforward. So that's what this says here. I've just covered that entire slide. So at this point, I want you to watch another video, which is one that I've linked into the playlist for the week, which is kind of fun. It's a little cartoon illustrating what I just said about pushing values along pointers as an assignment through a pointer. It has the, to me, slight disadvantage that it also introduces dynamic memory allocation through a function called malloc that I certainly do not want you to understand yet. We'll worry about that in the last week 6 of this course. So for now you can kind of disregard the malloc bit, but the rest of it's all valid and fun, and I hope you enjoy it. Thanks for watching. I've just explained all there is to know about pointers in 7 minutes. To recap briefly, when we declare a pointer, we go type star pointer name. And we normally initialize them to null, means they don't point anywhere useful yet. When we want to put something in a pointer, the thing we have to put in it is usually an address, which we get by using ampersand, or as you'll see in the cartoon that you're about to watch, using malloc. But we're not worrying about malloc yet, right? And we read this star after the type as pointer, so that's an int pointer. We read this star before the variable as indirectly through. Hope you enjoyed the video. Thanks for watching. Bye.